Alright, it's time for another math easy solution. Today we're going to discuss math paradoxes based on limits and infinite sums. Well, paradox is basically, it's a half-truth, or it's false and true at the same time. So it doesn't make sense. So an example, let's say this sentence is a paradox. Don't believe anything I say. This doesn't make sense because if you don't believe anything I say, then you believed what I just said. But if you do believe what I say, then you're not believing what I just told you to say. So that's a paradox. But anyways, here's some background on the ones that I'm doing. Some background typing here because writing it just takes forever. Okay. Let's say background on this. In the 5th century, a philosopher named Zeno of Elea. So he proposed several. So he proposed several math paradoxes to challenge the views on math and time and space of his time. And what he proposed, to say Achilles, which is a Greek hero in Greek mythology, versus a tortoise in a race. So what he was trying to argue was that if the tortoise was given a head start, then Achilles will never be able to catch up. Okay, I'll just explain what his logic behind this. Well, what he would do is, let's say you have Achilles here. This is Achilles. Okay, and this is time 1. There's him. And let's say you gave the tortoise a head start. So the tortoise is a tortoise, but you gave him a head start, so he starts all the way here. We'll call it, I don't know. So call it A1. That's the time. This is in terms of the tortoise where he is. So in order for, okay, so this is where the race is going basically. He's starting here. He's starting there. So by the time that, let's say, Achilles gets all the way to where the tortoise was, so this is, say, T2, by that time the tortoise has already moved, let's say here, so A2. So then by the time that Achilles gets to where the tortoise was again, it's called T3, but the tortoise has moved a bit, let's call it A3. So by the time, okay, so by the time Achilles gets to where the tortoise was again, and let's say here, that's T4. That's 4, not a. I don't know what it did there. Okay, by the time it gets to 4, the tortoise has moved a slight bit here. A4, and so on. That's 4. Why is it doing that? So A4, and so on and so forth. So this keeps going there, and it basically gets infinitely. So basically it never reaches it. So based on this theory, based on this logic, Achilles will never catch up, because this goes to infinity, so that goes to infinity small. And this is a paradox because it's clearly Achilles will catch up. It's just this can be applied to anything. If anything gets a head start, you could always catch up. But according to this summation, where as you see it's going to a limit as where it is. If you consider this as time, let's say you have the time from here to here is a 3 seconds. 3 seconds. And the time from here to here is, let's say, I don't know, 1 second. And then the time from here to here, let's say it's 0.5. Then here to here it's let's say, I don't know, 0.05 or something. It keeps going on. As you can see, it approaches 0. So it's basically, so you will have a limit here. The sum of this is a limit. Sum equals finite, meaning you have a sum. A sum, meaning you have a sum, and this is basically, and you're basically summing up decimal places. So there, you're just, the further down you go, just decimal places. Just decimal places are added. I'll show you an example in a bit. So here, that's one paradox. Here's another paradox. Say this was another one of Zeno's paradox. Let's go paradox 2. You can never reach a wall by walking to it. Now, what does this mean? You can obviously walk to a wall. Let's say you have here, you're here, and here's the wall. So in order to walk here, you would need to walk at a half a distance. Let's call this, this 1/2. 1/2 this distance, d. Okay, so you need to walk 1/2 d or whatever. And then in order from here, in order to get to here, you need to walk at least 1/2. So this will be 1/4, 1/2 of the half. I don't know why this does this. And then in order to that, you got to go 1/8, then 1/16. This all means in order to get the wall, you need to have crossed this. So I need to cross 1/4. I need to cross 1/16. I need to cross is 1/32. So as you can see, it keeps going smaller and smaller. Again, you're to infinity. You can go forever, but once again, all you're really doing is just adding decimal places. So decimal places. And this doesn't make sense. You can obviously go to the wall, but this is just saying some things you can't just really sum to infinity. So what we could do here is like this. Okay, let's say you have, what you could also do with sums, you could also, let's cross this out. You can have, let's say a number, let's say 0.3 on, or which equals to, let me just erase this. So basically, from this you could see that this is just like a physical meaning of summing up decimal places. For example, let's say you have the number 1/3. This just divides perfectly out, so you'll have 0.333, and it keeps going on, or it just, you can also do this. That's what it's called. So putting this thing above it, just put that above it. That just means that. And this could also be written as 3/10 plus 3/100 plus 3/1000 plus 3/10,000. So as you can see, it keeps going on and on and on. And this is just decimal places. The first one, second one. And in general, this is general, any number could basically be written like this. You'll have 0.d1, d2, d3, etc. And this just equals to d1 over 10. This is decimal place. Decimal place 1, decimal place 2, decimal place 3, all the way forever. Plus d2 over 100, plus d3 over 1,000, etc. So this is the first decimal place, second, third, fourth, and fifth, and on. So basically, this is a summation of decimal places. And this does have it does make sense. It's just all you're really doing is just decimal places. So in this paradox too, you're basically considering the length here, but finding the decimal places in every single one. So you're just going forever, although it seems like false, like, because obviously you can hitch the wall, but it's just the way you could explain it with limits and whatnot. It's just a paradox. So even with this, so this is a paradox, meaning it's half truth. And well, hopefully you learned today about paradoxes, then these math paradoxes, which involve limits as you get smaller and smaller, but you're still going for infinity. And also, yeah, when you sum it up, you basically have a number that has, you could have infinite decimal places, even if their decimal places are 0, 0, 0, but and so on. Alright, hopefully you enjoyed and learned a lot, so tune in for another math easy solution.